All right, question of the day. Tell me what you guys know about chemistry. About what? Chemistry.
You know there's a periodic table.
You know there's a periodic table. Good. What else?
I have no idea. There's elements in it.
Don't like it.
Don't like the periodic.
Don't like the periodic table.
That's what
Okay, there's solids and metals and non-metals. Are there gases on the periodic table?
Yeah.
Okay.
There's liquids.
And liquids. All right, we saw one of those yesterday. Well, when we talk about chemistry, there's really three basic terms we need to review. Element, compound, and molecule. What are the things that are on the periodic table? Yeah, what are those? Collectively called what? Elements. What makes it an element?
It's natural. It's by itself.
It's by itself. It has to be natural. It has to be by itself. Okay, what that's really saying is that it has to be pure. Okay, so an element cannot be broken down any further. It's a pure substance. That might be a good idea.
Happy space.
No.
Yeah, no, it's.
So our element is a pure substance that cannot be broken down any further. There's no subparticles, somewhat, that it can really be broken down into. So it's just a pure substance. But take something like something that all of us have in our body right now,
What?
Water.
and that some of us, especially as Americans, we crave. Yes, burgers. I do love burgers. You can never go wrong when you order a burger. I was thinking more in the lines of salt, sodium chloride. So what do we call that? A compound. So what's a compound? Two or more elements that are what? Combined. They have to be chemically combined. So it's two or more elements chemically bonded. So two or more elements that are chemically bonded. Now, so we talk about NaCl, sodium chloride, and believe it or not, you know that's basically just plain old table salt. And then there's another one that's really, really, really important to this class, and that is CaCO3. Anybody want to help me out here? What's the name of that? CaCO3. Well, the first word should be pretty easy. Calcium. What's the CO3? Carbon, right? We got carbon with oxygen. But when it's an O3, we call it a carbonate, ATE. And so this is called calcium carbonate. Guys, all calcium carbonated, limestone. Alright, so that's one of those that's kind of important to know for this class. You're going to hear that phrase a lot. And by the end of this course, you guys will recognize that CaCO3 is calcium carbonate. And that basically is dead sea creatures. So when we think about limestone, let's also talk about that. This big giant chunk of mud over here.
Where?
I borrowed this permanently from a golf course.
Trying to shoot that day.
This is just a big chunk of limestone. Most of you guys probably drive by some of the roads or ditches that might be lined with limestone. You don't think anything of it. It's just a big chunk of ugly gray rock. And most of the time, you're pretty much right. It's just an ugly chunk of gray rock. Not really that interesting, right? Pretty simple. Okay. Well, as I'm about ready to leave the tee box, I'm in my little golf cart. You know, I'm too lazy to walk at the course. I simply glanced over and something caught my eye in the middle of this ugly gray piece of limestone. This thing. No. That's actually a fossil. Turn this way. I'll pass it around for you guys to take a look at. So it's kind of neat. And when you look at the rock, you can see more fossils in here. Each one of these tiny folds is another fossil that's locked inside this piece of rock, including this indentation right here. So there's plenty of fossils to take a look at. And that's just calcium carbonate. It's a bunch of water creatures, any shells. We think about slugs, we think about snails. Anything with a shell, their shells are made out of calcium. And when those things die, the shells fall down to the bottom, and they can get compacted over time, and it turns into calcium carbonate. So limestone is like one of those really key rocks that help us understand our past environment. Here's another piece of limestone. What do you guys notice stuck inside here? It's a lot easier to see the shells in here. All right, so that's calcium carbonate. That's a compound. Two or more elements that are chemically bonded together. All right, the next thing I want to talk about is something called a molecule. So what is a molecule? Oh,
Isn't it like something
what do you mean?
like
No, they
more
Well, it's kind of a really difficult thing to define. I think you guys kind of get a general idea what a molecule is, but how do we actually define a molecule? Well, let's start off with this. Let's start off with H2O. Is H2O a molecule? No. H2O is not a molecule. In fact, what it's just a compound. And a compound is not always stable. So the molecule actually stabilizes the compound so that it can actually exist. So we have, think about water molecules, they're actually, each water molecule has two water compounds. Two H2O, that's your water molecule. So we have two of those. Now why is that important? Well, because basically, in its very basic definition, all a molecule is two or more compounds bonded together. So a molecule is two or more compounds bonded together.
wow.
So understanding that, let's go back to the basic concept of an atom. We understand that they're elements, they're pure substances. But what is an atom? What are atoms? Oh,
something that makes up like several.
makes up what?
Everything.
Everything, right? So atoms are the building blocks of matter.
I knew that on my CP.
And an atom of every element on the periodic table can be broken down further into these subparticles we call subatomic particles. So we're going to get even smaller than the atom. Okay. Now I'm going to bore you to death here for a minute. We used to think that the atoms were really this solid spherical thing. Couldn't really see them. We didn't have any tools that allowed us to see they were there through. So for a very long time, we thought these things were just very theoretical. We weren't really sure if they exist or not. It seemed like they would. Well, we weren't really sure. We had no way to test that. So we used to think that they were just like this big ball. Well, in this sense, really small ball. And then Rutherford decided to test this theory and see if you could somehow get smaller pieces out of that. And so then he shoots this beam of particles to gold through a gold foil. And then he had this screen behind that that actually received some input from this experiment. And that's when he realized that some particles were getting through the foil and some were not. And that's when it hit him. There's actually smaller pieces to these atoms. So after more and more research into this, we get to where we are today, where we have this idea of what the protons are, the neutrons are, and the electrons. And yes, we get even smaller. We talked about quarks and all that other wonderful stuff, which we're not going to get into in this class. We're just going to keep it simple: protons, neutrons, and electrons. In the center of the atom, we call that the nucleus. So this little guy right here, that's the center. That's called the nucleus. Just like the nucleus of a cell. It's the center of the atom. What are the things that go into the nucleus? Out of the three subatomic particles, protons, neutrons, and electrons, which ones are in the nucleus? Tanner, did you just learn this? Which of the subatomic particles are in the nucleus?
Protons.
Yeah, that's one of them. And neutrons, very good. The protons and the neutrons are in the nucleus. So your protons and neutrons, these are in your nucleus. And the electrons, are in the outer shell. That's not working out too well. We're giving up on that. All right, so when we think about our protons, and our neutrons and our electrons, the electrons actually fill up these shells, right? And when we think about the atom, again, when we think about these shells as layers, okay, layers of electrons that get built in there. And so when we look at the first layer has exactly 2 electrons in that first layer. How many is in the next layer?
6, 4.
Yeah, which one is it? It should be 8. So we have 8 electrons in the next layer. And now notice how I'm actually filling these in. 1, 2, 3, 4, 5, 6, 7, and 8. So we have 2 and then 8. So how many do we have right now total? 10 electrons. Okay. And let's just throw another 2 electrons out here in our outer shell. Okay, but again, it should basically be 2 and 8 and 8, and then we'll talk about why that is tomorrow. We might get to that today. It's kind of important. All right, so electrons are in the electron cloud. And the reason we call it electron cloud, again, if you guys are kind of interested in this type of stuff, it's kind of interesting. It's called the Heisenberg principle. It's kind of neat when you think about it. The electrons have such low mass that when we think about light, light acts as a wave as well as a particle. And those particles are called photons. Well, the electron's mass is so low that the photons from light can actually move them. And they actually collide. Just think about it like the billiard balls on the table. You know, it's so light that it actually will knock the electron out of the way. So we have this Heisenberg uncertainty principle, which basically states that you can do one of 2 things. You can either know where it's at, or you can know its speed, which you can't know both. And the reason is that as you're observing the electron, you are therefore putting light and energy into the system, which therefore disturbs the electron. And so it's actually very difficult for us to see the electron. So what we actually do see with microscopes is this gray haze look around the center of the atom. And that's the electron cloud, because they're actually moving so fast, it actually just looks like this cloud of stuff. It's kind of neat. Okay, so that's called the electron cloud. By the way, really important concept here to remember for this class. Make this down here at the bottom. Everything in nature is trying to reach equilibrium. Everything in nature is trying to reach equilibrium. What does that mean? What is equilibrium? Balance. Okay, we're trying to be happy. The whole reason why rivers down cut through the ground is they're trying to get to their base level, which is the ocean. And they're doing anything they can to actually get there. Okay, so they're trying to reach the equilibrium where they no longer have to down cut. When we think about atoms, a happy atom or a balanced atom has a full outer shell. When we look at the atom we just drew up here, how many electrons are in our outer shell?
2.
2. So now we have 2 options. And again, one of the things you might want to remember is that nature is inherently lazy. Kind of like mathematicians. It does as little work as possible. So you look at this atom, and you ask yourself, okay, what's easier? Do I find 6 more electrons to fill that outer shell? So I got to have a total of 8 in that outer shell. Or do I just get rid of the 2 that I have? What's easier, find 6 or get rid of 2? A lot easier to get rid of 2. So what this atom would do is basically it would get rid of those by either transferring it, most likely it would transfer those out. And we now have our full outer shell. We now have a very happy atom, and that atom has now reached equilibrium. Okay? And that's what chemistry is all about. If you want to know what it's all about, it's right there. It's all about the atoms moving around and shifting and sharing and balancing out, all in an effort to reach equilibrium, trying to get full outer shells. So that our whole unit, our chemistry unit that's starting today, that should be a hint as to which folder you need to look in for the notes. Okay, it'll be the chemistry unit folder. And everything we're going to do is going to constantly go back to this question. What do the atoms have to do in order to have a full outer shell? So what I want us to do now is understand that concept we have to have this full outer shell. This leads us a little bit into the periodic table. And we're going to go into that in more detail tomorrow. But today I thought it would be kind of nice just to have it, take a look at it. By the way, this will be the only copy you get. But you can use it on every test here for. So please don't lose this.